thanks for everyone for being here today. If you don't know me, I'm Allison Wood. Today I'm going to be talking about my favorite material of glass. A lot of you already know me, so I talk at length about this material with my students, but also to my family and friends, so it's kind of become an identity for me in a lot of ways. Okay, so I want to start off by saying one thing. Glass isn't trash. I am so thankful to be able to talk with you today about my favorite eternal material of glass. And I am so nerdy and happy to be here. Okay, tonight's presentation includes a few chapters, so I'm including an introduction for those of you who might not know me. My current title's the topic of glass as a material, and my research in this field from the last decade and a half. I'm also including my work in the last year specifically, and any closing thoughts. Okay, so again, I'm Allison Wood. I'm an artist, designer, maker, and fabricator. I teach full-time at the Kansas City Art Institute in the new product design department. I'm a millennial. I'm also an Aries, which, if you aren't into astrology, it's the first sign of the zodiac, and it is a fire sign. Yeah. For those of you who are makers of any kind, I wanted to start my introduction with one of the best tools in my practice, an app called 1 Second Every Day. It's free, and this tool encouraged me to activate my time every day with one creative contribution so I can capture the best 1 second of my day on video. This app rolls all my progress into a quick summary video and helps me document and see the patterns in my creative work. I've compiled the relevant clips into a 2-minute video so you can see my practice through my eyes.
Supposed to be. Pick 'em up.
Get this.
Sweet.
Trim.
There's nothing.
But
Wow. Sorry, I haven't seen that one, guys. This is good.
that was a year's worth of video, and it is so easy to forget everything that happens in that period of time. Okay, so I want to talk about my interests so that you have a bit of understanding of where I've come from, just generally, and my curiosity. And this is a story about how my interests all come into a singular path of glass. It's funny to think retrospectively about some of these topics since they've occupied my curiosity for most of my life. First, I was always interested in art. My parents enrolled me in art classes from age 5 onwards, mostly at the Nelson Atkins. There I was exposed to all forms and histories of art. What I knew is that the Egyptians were my favorite makers, both in 2D and 3D. Second, my exposure to design has been mostly in the vein of mid-century style, as my grandpa had a beautiful mid-century office that was unchanged for years after his death. I mostly knew him through those pieces of furniture. It took me a while to come to realize that the materials and the approach of this design movement, mid-century modern, would be important to me philosophically. Also that it took me about 23 years before anyone called me a designer. Lastly, the value of ecology. Since I am a millennial, school supported an interest in sorting trash through material types, no longer writing on commingled waste streams. This is a more modern approach to our human waste problem. More on that later. Okay, so for art, ancient Egyptian hieroglyphics, symbols, simplicity, graphic design, communication design. Archaeologists have found glass beads dating to as early as the 3rd millennium BCE. But it was in the late Bronze Age, 1600 to 1200 BCE, that the use of glass as a singular medium took hold in Egypt and Greece and Mesopotamia. Who knew that my interest in Egypt would somehow point to glass? I spent most of my childhood committed to the idea of becoming an archaeologist, and specifically an Egyptologist, long before I had ever found glass. For design, as a kid, I was interested in an artist who you may know as Allison. I was in middle school when I asked my dad for a specific birthday gift, a coffee table book on Oliver's work, so big it came with its own briefcase. Oliver's work not only covers art and design, but it is also critical of ecological impacts. This building is Harpa Hall. It's in Iceland, and it has a type of iridescent 12-sided building module made of glass, inspired by crystalline building structure. From Henning Larsson's website, the consulting architect on this project with Oliver Allison, they say the building's iconic facade draws inspiration from the interlocking hexagonal basalt formations found along Iceland's stormy coasts. And again, there's ecology. I teach about various design theories, but cradle-to-cradle design theory is one that really persists in my research. What is made must be made with the end in mind. Once you've made something, is it possible to reclaim those materials for a second life? Maybe an infinite life. What is the impact on our environment when we consume certain kinds of materials to create? I definitely did not write a letter to Hillary Clinton about the implementation of green energy in 6th grade. My material choice, as you're already aware of, is glass. It's one of the most infinitely recyclable materials on the planet. Statistically, the rate in which glass is recycled is slightly less than steel and paper products, but nothing is as beautiful as glass, in my opinion, while still being safe for human use and the remaking or recycling potential. Wait, this isn't a recycling symbol. This is an Uno reverse card. Let's do a quick rundown of my education. Okay, 90s kid. The 90s was postmodern design at its height, a mainstream aesthetic of consumerism characterized by playful, eclectic, and subjective styles, often with complete disregard for environmental impact. Still, the value of truth, authenticity, and transparency remains. These were the things that I was really obsessed with as a child. After being an art kid my whole life, I went to art school for undergrad. This school gave me the opportunity to explore my creativity and a wide variety of materials and processes in the sculpture department. I felt drawn to the material of glass for as long as I can remember, so when I finally found a 3-credit class called Kiln Form Glass, I knew it was a good opportunity. The course was offered through KCAC's ceramics department, and in this elective, I met George Timmock. He was the faculty. He's known as a very renowned ceramicist, very loved professor, and eventually my mentor. George was a force of curiosity, positivity, and light. He saw my interest in glass and chose to foster my practice personally. His presence and support fully shifted my career into the glass world. I took his class 5 times consecutively. Although he no longer is with us, his hand is in many aspects of my approach to teaching and making every day. So I got my BFA in sculpture and a minor in kiln form glass. This process of glass resided inside a kiln, often using methods such as fusing flat sheets together, melting and casting glass fillets or chunks of glass into molds, and slumping flat planes into 3D vessels. I also found a deep interest in cutting glass in every way possible. At this time, I would create rubber stencils with designs that I could sandblast through the glass, creating holes of all shapes and sizes that would then be fused between whole sheets. This effect created a trapped pocket of air that would puff up and raise the surface in a tactile way. George would always be amazed when I could cut a circle out of glass without breaking away the exterior frame. He made a hall of fame for me that he called the one-shot circle cut. It's still in the basement of ceramics. He would say, "Wow, wow, wow." And even now I can hear his voice in my mind when things work out perfectly. George was the conduit to my post-grad training. He helped secure a scholarship for me to learn how to blow glass for the first time in 2013 at Pilchuck Glass School. This is a world-famous facility north of Seattle, Washington. Originally built and started by famous glass studio artist Dale Chihuly and friends back in the 70s. This summer program draws all kinds of glass people with classes on glass blowing, fusing, slumping, casting, flame working, neon, printmaking with glass, cold working, and many more. Anyone can sign up for these classes, and the school offers courses from beginner to advanced. My first course was from some Australian artists, Gabriella Bizzetto and her team from Adelaide. Gabriella was the first person to ever suggest I might be a designer when she saw my sketchbook. Hot glass was an amazing and intense material to get hands-on experience. I knew the process was what I really wanted and how different it was to see it outside and outside the closed atmosphere of the kiln. Pilchuck was also a notable networking opportunity for me. Everyone who is anyone in the glass world has some experience here. The first session I spent at Pilchuck, I met Dale Chihuly and he signed my sketchbook with one of his famous drawings. It was also in Seattle, specifically Tacoma, Washington, that I got an opportunity to assist at the Museum of Glass, which has a working hot shop and an online live stream. My dad took a screenshot of me with Tyler Kimball. Because of my time at Pilchuck in Seattle, I was able to secure an apprenticeship with Rock Cottage Glassworks. That's a local Kansas City hot shop. Owned by Dirk Van Keppel and operated since 1991. His work is full of color and flat plates called rondelles. We often made these over and over again as a production glass shop. These pieces would sometimes be fused together and then water jet cut for large installations of private and public art commissions. I spent 3.5 years learning about the intersection of art and architecture at Rock Cottage Glassworks, fabricating with Zahner metal, and designing public art. This was a massive apprenticeship. Our group has done many projects you may recognize, including art for Children's Mercy Hospital, Leawood Aquatic Center, KU Cancer Center, and Arrowhead Stadium, to name a few. I still work with Dirk after 13 years. when he needs digital design and fabrication, which is something that I developed when I went back to school for my graduate degree at K-State. Finally, my education came in at K-State's School of Architecture and Planning in Manhattan, Kansas. It was there that I studied interior architecture, furniture, and product design. The school made me fully into the designer that I am today. I learned so much about digital design methodology and how to be a real-world designer who could turn concepts into reality with the help of digital fabrication tools like 3D printers, laser cutters, and CNC routers. There's CNC routers seen here in their 20,000 square foot wood and metal shop. I still use these processes today in art and design making. The CNC router walnut project pushed me into a proficiency beyond most of my peers at K-State. I love CNC routering. Today, I own a small CNC and use it to carve and cut lots of different materials. And this recliner was my thesis project on behalf of a contract furniture company called OFS. It was designed and fabricated for the boomer demographic as they move into long-term care environments. Okay, after I left K-State, I heard that KCAI was launching a product design department in 2020. I am so thankful to teach in this department. My students are alive and so curious. We are supported by the recent campus addition of Beal Studios, which is our Fab Lab facility. The space is a shared facility for anyone at KCAI to access 3D printing, laser cutting, CNC routering, and my latest obsession, water jet cutting on the laser. We call him Willie the Wazer. You'll see evidence of the Wazer across my work, but this water jet is really a continuation of how I can be precise when it comes to cutting exactly what I want out of glass. The Wazer uses garnet powder in the water stream, and this material, this is the material that actually abrades the sheet glass, not the water. The Wazer can also cut through ceramic tiles and various metal. On the left, you can see a very thin, very delicate cross cut from a single sheet of blue glass. This cut would be absurd to try to do by hand. The reason why we call him Willie is because sometimes he doesn't like to cut, and so we always ask, will he or won't he? So his name is Willie the Wazer. Aside from being at KCAI, I'm continually in the glass blowing studio at Rock Cottage Glassworks. I often have students come assist me in blowing different projects. I'd say the most exciting development here has been the overlap of student interests, digital fabrication, and the traditional glass blowing process. At this point, we've made special blow molds with either CNC router or cherry wood, which we soak before we blow hot glass into. And now we're using wet plaster molds to create unique products that would be impossible to shape with the traditional methods of glass blowing. This shop continues to challenge and support my growth in my art and design practice. I feel like I'm seeking precision, efficiency, and consistency with most of my work nowadays. I think these values mostly come from my design training. This is when we rebuilt the furnace. I literally felt like the Egyptians building the pyramids. Okay, so let's talk about glass. Hot glass is hot. 2,200 degrees in the furnace hot. It's a melted mixture of sand, soda ash, and limestone. To get the glass hot, it is loaded into a furnace that holds a crucible pot. The glass will take many days to fully melt into a honey-like consistency. Side note, for all your geology nerds, there are natural glasses and man-made glasses. Natural glass is formed through intense, rapid cooling geological processes like volcanic events, meteorite impacts, and lightning strikes. Key types include volcanic obsidian at the top left, impact-formed tektite such as moldavite that is green, Libyan desert glass on the left, and lightning-struck sand known as fulgurites at the bottom. These materials are amorphous, lacking a crystalline structure different from crystals or geodes. and often contain high silica content, much like man-made glass. Okay, so man-made glass. Types of man-made glass formulas include soda-lime glass, also known as soft glass. This is about 70% of the worldwide glass content. So statistically, if you pick up a piece of glass, it's most likely soft glass or soda-lime. These are the common glass products that do not get exposed to high heat or large forces. Top left. Lead glass, commonly referred to as lead crystal, top right. Borosilicate, also known as hard glass, which is great for high heat exposure, usually in scientific instruments, Bunsen burner situations. And then aluminosilicate, also known as AS glass, which is typically used in smartphones and other electronics. My practice really centers on soft glass, the first type, and it benefits me because it's also the most common and easily found. Okay, so man-made glass can be purchased in a wide variety of products, most notably in sheets. Historically, the sheets were made by blown bubbles, turned into cylinders, and then cut and flattened into rectangular sheets. This craft yielded many panes of glass worldwide, but the 18th century to today, from the 18th century to today, although this practice is pretty rare at this time. These sheets were not perfect, typically with varying thicknesses. It is a massive misconception that glass is a slow-moving liquid based on old window panes seemingly having thicker edges at the bottom, supposedly from gravity, when in reality the glass was inconsistent from the handiwork process. The color. The color in glass is made by adding metal compounds, specifically metallic oxides, sulfides, or rare earth elements, to molten glass during the melting process. These additives absorb specific light waves, creating vibrant colors, or are added as powdery frits to coat the glass. Blue is made with cobalt, green with chromium oxide or iron, red with selenium, copper or gold even. Red tends to be a very expensive color in the glass world because of this. Purple has manganese or nickel, yellow amber uses sulfur, cadmium, sulfide, etc. Other types of commercial glass materials include frit at various mesh sizes from powder to very coarse rock-like pieces. Glass blowers will often use color rods and color bar to include in their blowing processes as well for a more consistent color coverage. Glass research! Okay, so this is a little bit technical, but it will be quick. I want to talk about this thing called the coefficient of expansion because it is the main ingredient in where I am today. So, COE stands for coefficient of expansion, scientific term, basically for how much glass expands and contracts as it's heated and cooled, right? It is critical in glassworking to ensure compatibility when it comes to mismatching COE values. It can cause cracks due to stress. Not all glass is the same. This is art glass. Can anyone tell the difference between these two images? No. The one on the left is Bullseye glass, which is a certain brand, and the other is System 96. They look essentially the same. That's kind of a problem because they're different COE. They're different coefficient of expansion. Yikes. Boo. All right, so in art glass, 90 COE, which is typically Bullseye glass, and 96 COE, System 96, are standard non-compatible standards, meaning they cannot be mixed in fusing projects. Stresses in the glass will form when incompatible glasses are melted and cooled together. A polariscope can visualize these stresses. The main point here is that the glass is seemingly just alike to the naked eye, but often it is an uphill battle for fusing artists to be able to tell the difference between types of glass and their corresponding COEs. That can spell disaster when it comes to melting glass together. Every single type of glass has its own type of COE. Deciphering what that COE is very scientific and it takes a long time. worked on this project using recycled sheet glass to put it in the kiln and have it be ruined. Yeah, sad. Not compatible. This is an image of a polariscope. So if the glass is translucent enough, you can actually see where the glass as a material is stressed using a polariscope machine. It's very scientific. Most glass artists don't do this, but it is a nice way to tell if your object is actually safe or not, because some things may seem to be stable for a period of time, but if they are internally stressed, they're bound to break, bound to crack, bound to fall, bound to cause harm in some way. Okay, so although annealing kiln schedules can cause stress in any piece of glass that is undergoing this temperature transition, the mixing of an incompatible coefficient of expansions will undoubtedly create trouble during the cooling process or afterward. Each kind of glass has a specific series of temperatures and lengths of time to safely bring the material up to a working temperature and then back down to room temperature. Okay, let's talk about general types of glass again. Soda lime. Soda lime COE has a range, which makes it a little tricky sometimes. It's about 84 COE to up to a high of 96 COE. It's hard to say where any one piece of glass really falls without scientifically measuring it. I've never done that. This range can make it very difficult to mix recycled glass bottles into one fused or melted piece. Some of these bottles are so stiff because they've been formulated to cool quickly for the rapid blow mold assembly line. More on this in a minute. All right, borosilicate, hard glass. Borosilicate has a very low COE, typically around 33, often offering high resistance to thermal shock, which is why it's usually used in high heat situations like laboratory equipment and experiments. You'll also see this as Pyrex. All right, and then art glass. So this is how much of art glass is made commercially today, unlike the bubble method that I showed before. There's an amazing studio called Kokomo in Indiana who produce these sheets from furnace glass in a wide variety of colors. One day I would love to be able to formulate a method for flattening furnace glass for stained glass application. Okay, let's talk about environmental impact a little bit. While glass is infinitely recyclable, new raw materials have to be used in each batch, at least 40% virgin materials, which means that even though recyclability is high, raw materials are still being used with every batch of glass made. Worldwide, the demand for sand is so high that rivers and floodplains are being stripped, causing further ecological disruption and destruction. Glass production is reliant on mining practices around the world. So really high demand for sand just in the glass world. Another true cost is that artists and designers don't always have the budget to buy the material. They say necessity is the mother of invention. So how can makers use this material without spending thousands of dollars on their supplies? I've read about this many years ago, but creatives are the people who see beauty and potential where others don't. They are the first to beautify and bring value to places where there is none. I think I've always seen the material of glass in this light. And finally, not all glass is recycled. Even less gets remade into new product. And if you know anything about the recycling industry, many objects get wish-cycled, put into a bin, shipped away, and then who knows? Hard truth, but recycled glass doesn't always go into new glass containers. I've always had a difficult time throwing a piece of glassware in the trash. So I've been diligent to recycle the material. Now I reclaim a lot of it myself. It's amazing the types of products I choose to consume now that I'm conscious of the product container that I'm also consuming. Okay, let's talk about projects. Okay, this is a screenshot of Etsy. The beginning of my stained glass practice was a commission from my aunt. She was hoping to purchase a Chiefs arrowhead from Etsy, and I asked if I could, and she asked me if I could instead make an arrowhead for her. I do love a challenge. I started in a traditional assembly for this project with broken regions that are cut and ground by hand to fit together with solder. Phew, this is tedious work and it often is imperfect. This method was not ideal for my interests of precision and efficiency. So I went to the fab lab to see if the water jet cutter would yield the right amount of spacing between pieces of glass for the solder. Fun fact, the kerf from the water jet stream is about 0.6 millimeters, very small. This is ideal for adding a thin amount of copper tape and then soldering shapes together with a perfect fit. The copper foil method in stained glass is commonly referred to as the Tiffany method and is super common in the DIY world. Test cutting the white glass on the Wazer. This machine we have lovingly nicknamed Willie because some days cutting is rife with troubleshooting the machine's intricacies. So we don't know if he will or will not cut, will he or won't he. And this is the garnet abrasive. This is what does the cutting in water jet cutting. Mike serve at KCAI and I have found that with enough sifting, kiln drying, and reuse, the garnet can be recycled as an aspect of the workflow. So this also can be a closed loop system if you take care of the material. I found that it was a perfect amount of kerf or spacing between the glass pieces for stained glass construction. This process can be exceptionally satisfying when the Wazer cuts well, and the work becomes a playful puzzle of color choice. For these initial projects, I was also testing a laser cut hardwood framing system. As a designer, wood is a warm and inviting material for touch. Most stained glass is finished with a lead or zinc U-channel trim, but the metal doesn't appeal to my senses the way that walnut does. Okay, so this is a finished test product. I found these to be helpful in moving through a very different creative process than being in the hot shop or the fusing world. I also found that the stained glass always looks best in daylight, as most people would expect. The interface with the sun and windows and backlighting brings up a sense of hope, optimism, and appreciation for the natural world and the changing sense of time. I didn't expect to feel all of these benefits from a simple commission project, but this was a meaningful portal for me to move through in my creative life. Okay, so this is where my design voice starts to come into play. Obviously, I wasn't interested in copyright infringement for my creative practice. This is a screenshot of a massive 3D file where I think about form in an isometric view. All drawings seen here are made from 3D models and then flattened into vectors. The vectors can then be used in laser cutting, Wazer cutting, or vinyl plotting. These images are a lot like the Egyptian hieroglyphics I obsessed over as a kid. Many of these symbols hold stories of hope, persistence, change, and success. So I began making portals with arched openings. These are some of my first shapes to assemble my miniature doors. While they are subtle and satisfying as homogeneous assemblies, I prefer to mix tones and levels of contrast. The beautiful part of these isometric images is the play between 2D and 3D illusion. The opening of the portal may appear as though we are either looking down on the object or from below the object. This was my first portal soldering. And then me hanging the first portal in my window. This piece is finished with a U-channel made of lead. The solder and metal combination looks okay, but to the touch, the object feels so gross to me. The active heating solder that contains lead has forced me into a world of PPE and lead contamination mitigation. It is not ideal for my health or for those who might touch the materials. Okay, so I kept moving forward in the stained glass Tiffany method because I had 2 more projects I wanted to complete without changing all my variables. I created a diptych with 2 larger designs for my Rhino world, my 3D modeling world, called Boundary and Closed Loop. These projects are now in the KCAI alumni store called Marble and Canvas, open April 4th. This is picking out different colors to use. I almost always print my digital designs so that I have a roadmap for my puzzle. This project was more complicated than my arrowheads or the portal projects. That is something I always carry with me, is the ability to have shop drawings produced for a more precise fabrication workflow. More on that in a minute. At home, I set up my office to be a stained glass studio. Sorry, Josh. I have this lovely IKEA table, dining table, that has a glass top on it. So I inserted some lamps underneath to make a makeshift light box. This is the final frame boundary piece. And this is the final frame closed loop piece, installed at the KCAC gallery for the alumni show. Again, wood border, wood frame. Feels good to hold, safe to hold, good for my health. At KCAC, I support a lot of ecological initiatives. Sometimes we're collecting e-waste for donations, sometimes we do clothing drives, and we are always diverting glass waste from the commingled trash bin. Glass isn't trash. My student Zoe Still and I had the idea that maybe we could reheat the wasted containers that we were already collecting and recycling with Ripple glass. From something like this to something like this. I cannot for the life of me figure out how a glass bottle is a single-use product. But Zoe and I are reclaiming one bottle at a time for a longer life cycle. This is how we make these products. So this is in the glass shop. We make a collar of soft glass by gathering a small amount from the furnace. This is the marver, which is a metal table, where we roll the hot glass along so it's cooling down and it becomes the right shape. We must preheat all of the glass bottles so that they're warm, so that they don't crack when we touch them with hot glass. The ones we really like are Topo Chico mineral water, light green, Topo Chico twisted lime, dark green, and Saratoga sparkling water, blue bottles. Fun fact, the Topo Chico we usually drink at school, but the blue bottles are essentially trash, from Zahner Metal. I guess they like it a lot over there, and we really like their waste. We pick up the whole bottle and puff it up into a cast iron mold to give it a new look. This formula of glass was created for the assembly line. Very tricky. It means that it cools down much quicker than typical soft glass formulas. We do not know the COE of these bottles. It's basically impossible to tell. It's very tricky to work with, but Zoe and I have really persisted in using this material. All of the manufactured glass bottles tend to be very stiff and they cool down very quickly, so it's very hard to change them. After heating the neck, we trim down the top to about a 4-inch drinking glass height. This is one of my favorite processes. We do this so many times in a production day, I end up getting a little blister on my finger every time. But I love it, it's very satisfying if it's hot. And then we straighten the wall of the glass after we trim it. And the final step, so that it cools very slowly, is to put it away in the annealer to stay warm until we're done for the end of the day. After the end of the day, we set the annealing kiln for 12 hours to slowly bring it back to room temperature. Good job, Zoe. Okay, so these are our final colors as of today. I personally really love the clear with a subtle hint of green, just because it feels quite refreshing as a drinking glass. The last project I really wanted to talk about today is kind of a secret, so no photos. I wanted to discuss this project that I finished February of 2026. It was for the Parade of Hearts. How many people know what that is? Some people? Most people? Thanks, Bubs. Okay, so I'm on the board of a local creative reuse nonprofit, and it's called Magpie Creative Reuse. similar to scraps. If you're familiar with scraps, they're just on the street. And as a board, we are always looking to add fundraising efforts to our nonprofit. So as a board, we agreed that I should submit a proposal for the Parade of Hearts 2026 public art call. I have experience in public art. It would raise a little bit of funds for us. It was like a win-win. All right, so this is a rendering from that submission. This was a 3D model. This object is now complete, a little different than the model. But the idea was to use all upcycled materials to decorate the heart with scrap glass, scrap aluminum, and bring the community together to do it. Okay, so we made this intricate project in a matter of 2 months. Magpie has an education space that we hosted 4 volunteer nights, teaching people how to cut glass for the first time, how to mosaic, how to mortar the large scale sculpture, and finally how to grout. This project required so much coordination. I could not have been able to execute this design without the support of Kelly Campbell. The design is literally 4,000 pieces of hand-cut glass. Kind of makes me want to throw up. There are 2 shapes in the design, which is great because that keeps it rather simple. It's either parallelograms or squares. And this was the original blank fiberglass sculpture that all 150 artists who get chosen are given. The intent is to decorate it, yeah? So we let the community engage with the process as our new Magpie store opened up in the Roanoke area. If you're familiar with scraps, it's just down the street. Okay, so each piece was glued to a fiberglass matrix, assisted by a printed template to guide the continuity of the pattern. This is 4,000 pieces of glass. They have to be perfect. Okay, this sculpture took a lot of patience, persistence, and careful tabulation when it came to how much sheet glass we needed, how much we had to cut, and the coverage we could expect on the entire surface. The colors were random, but some of the hues were rare, and I wanted the project to look evenly distributed. Also, none of the glass was purchased outright. We applied the fiberglass mesh pieces onto the heart with a mortar. And then we grouted over the whole thing and cleaned. The project was something I contributed to every single day for a 2-month period. It was physically and mentally demanding, but it was also so satisfying, and it didn't kill my interest in glass mosaic. The magic was bringing all these disparate materials together for a unified work. The design proposal also included an aluminum magpie bird and a nest in the heart cutout. This is crazy, but I had snagged this aluminum sheet off the street 2 years ago with no intention until this project came out. I was just holding on to it because I'm kind of a hoarder. This is my home CNC working hard to cut my design out of this roadside trash. I broke 8 bits. It was really it was a very difficult process. Thanks, Shannon. For your help. This project will be on view to the public starting this spring. The location is not yet posted, so I don't know. But I'm excited to see it in the wild. One of my favorite found materials is this opalescent gem eyeball that Zoe and I had found in the basement of our building at school. It's a very specific detail, but I really love it. And it's also found material. Okay, so recap. Glass has supported my mental health, my urge to fabricate, my interest in ecology, and a drive for community connection. Moving forward, I'm hoping to start blowing or rolling my own sheet glass and understanding that history from a more hands-on perspective. Overall, I believe that taking sustainability into my own hands, especially as a maker and a designer, to transform waste into form and function is best done one piece at a time. Thank you. Anyone have questions? Yeah.
I'm curious with your research if you found any objects that you were surprised had a glass component in it.
No, I don't think so. It's a good question. What else? Robin?
When you are putting your wooden frames on your stained glass pieces, are you soldering the edges of the glass and putting all of that in a inlay slot in the frame, or are you just using glue?
So I do a process called tinning, and it's a very thin amount of solder that coats the copper foil so that it turns silver with the solder, but the amount of mass added is almost negligible. It just changes it to be more cohesive and coherent with the rest of the solder. So if you did see that edge, it would look silver, but it's not as thick as the seams. Does that make sense? Yeah. What else? Lulu?
Tell us about your wooden frames that you've been working on for your portals.
Yes, good question. Okay, so like I was saying, the lead solder is just not great. It's not great for your health. These aren't quite finished, but they're almost there. They need a little bit of like wood finish on them to be complete. But these pieces of wood are safe for my health to use, safe in the process of cutting them on the laser cutter. And if I give this to a child and they put it in their mouth, they're not going to get lead poisoning. And for me, I worry about that. I don't want to be exposed myself, but I also don't want anyone else inadvertently, without their consent, exposed to lead. So, thank you. Yeah. I also have this one, but it's a different color scheme. Very juicy color. Yeah.
How much lead is
In the solder?
Yeah, like is it that?
It is a 60-40 mix, and I can't remember which one is which, but either 60% or 40% of that content is lead.
So like anytime I go touch like pretty much any stained glass, I
Yeah.
should be concerned.
You should wash your
How much
hands.
Good to know.
Yeah. Also, don't lick it. Also, technically, if you're so committed and in love with the process of stained glass and soldering, you can get 100% lead solder, or not lead solder, silver solder. But silver solder is wicked expensive, so it's kind of out of reach for most people. Other questions?
Yeah, you mentioned that you didn't buy any of the sheet glass for the rail parts.
Yeah.
Where did you source all of that sheet glass then?
Yeah, so there is a local stained glass artist, Tara Concert, who donated a lot of scrap. I also have a lot of scrap. I think if you talk to any glass artist, especially sheet good glass artists like stained glass artists or fusers, they have so much scrap. They end up with 5-gallon buckets and buckets and buckets of little pieces. So I used full sheets, but I also used scrap pieces as well. But all of it either came from my studio or Tara's studio locally. And frankly, most of that does go to a waste life cycle because they end up so small. But also, that's a great outlet for mosaic design and like artwork that's based in tiny pieces. So to me, glass still holds a value even at a small scale. Yeah. Other questions? Yeah.
You talked about your concern with the environmental use of glass and how we just throw away bottles and things like that. What is your kind of take or opinion on the influx, or I guess increase of glass in places such as like thrift stores or secondhand stores?
That's my opinion on it.
I guess, yeah, do you worry about, I guess, an overconsumption of products in our society, just like putting more glass than we know what to do with? In secondhand shops, I guess, what would be your take or opinion on things like that?
I don't know if I'm worried about it. There's something that I also thought about during this presentation because I talked about sand. Because the sand is the main ingredient to make blowing glass, like soft glass that we melt. So we're eroding the glass, the sand in our environment because of those mining practices, those like harvesting processes. But it's kind of ironic because if you look at what Ripple Glass, which is the local recycling company, does, they're mostly making sand out of their glass product
I was just going to
as a product.
And put it back with the glass in it.
Yeah, there's a company specifically in New Orleans who are taking all this glass trash and breaking it down to a granular level and then making sandbags for the sake of like eroding shorelines, but also like flooding, because obviously New Orleans has that problem always. So ironically, I feel like the influx of glass could still have a home.
Okay, so you can still revert glass back to sand.
It's
in
a
spite the
kind of
CO2.
sand, but it's not the same makeup because it's glass beads essentially, just very, very small pieces of glass. It's not necessarily officially sand as we would naturally harvest it and mine it, but it does hold similar properties and can still be valuable and functional and applicable. So I really don't worry about it over consumption of glass because it can have a second life as long as you're not trying to melt all of it together.
Okay.
Yeah, anyway. Okay.
You talked about using a polariscope
Mm-hmm.
during the studying the structural integrity of different glasses.
Yeah.
I'm curious, as you're coming up with different ways, creative reuse of glass, do you ever consider using this in your practice?
Yeah.
In any way?
Yeah, it's actually pretty cheap to set up.
I actually looked at the price when I was looking at
Well, there's like a DIY way to
Yeah.
build your own polariscope, and it involves like a TV monitor set to like a white color, so that the light is coming through the screen and it's like a pure white light. You set your glass piece in front of that white light so it's backlit, and then you analyze how much color and halo effect is coming through a final layer of that polarizing film, which is essentially what sunglasses are made out of, and that film is not expensive to buy. So if you need just an old monitor and a piece of plastic, it's actually pretty reasonable to set up if you want to be able to see the stresses. The cool thing about the polariscope also for our industrial designers is that if you look at injected molded plastics, if they're translucent or transparent, you can also see the stresses in plastic, which is kind of cool too. Awesome. Yeah, it's very specific, but kind of cool. It's ironic because in the glass world, we generally say no rainbows. It's really specific. Most people don't understand that. But in the polariscope, you don't want any rainbows. You don't want a halo because that means there's stress. So. Other questions? Yeah.
So you said next you're wanting to do blowing and rolling. Is it possible to do that with scraps? And is that your intention to keep using reclaimed materials?
Yeah, it is. I'm always looking to kind of save that piece of glass. It's just like a weird complex. But the guys in the glass shop who are there every day running production, they tend to cut pieces of color, ribbons of color off their work, and they're like, oh, that's trash, whatever. No. I'm there to sweep up and take it because those colors are expensive. And if I know that it came from the glass furnace and that they included a certain type of glass color bar in that process, then I can absolutely melt it back in with clear glass, mix it together, squeeze it through some rollers or blow it out and flatten it. As long as I know that the types of glass are the same, I will remelt them. And if I don't know that they're the same, the odds are that they probably won't work. They'll be incompatible. So, yeah. Absolutely.
Yeah, I was curious, how does one support their local glass artists? And I was thinking, do we collect the things and then reach out and be like, hey, we have this stuff, but then if we don't know the COE, then it's not a helpful tool. It would be more like, you'd be like, hey, take it to Ripple.
I think if you don't know the COE, then yeah, take it to Ripple, that's fine. I think that's a typical approach, is to just say, leave it to the experts.
No.
For Zoe and I, we're hounding people daily at school to drink the Topo Chico and do not throw away the bottle because they end up as cups, right? And this to us as our cultural understanding is a single-use object where this being remade into a very similar form does not yield the expectation of trash, which is kind of wild because they're really not that different. But yeah, if you want to support Zoe and I's practice right now, we're doing a lot of cups. So if you have any Topo Chico
and Saratoga water.
Saratoga water, which is from Costco. Fun fact, also depressing fact, right now, these bottles are rare, but only for a period of time. Zoe and I have bought maybe like 6 cases of 12 packs in the last couple months because we're trying to like have enough to drink and make into cups and glasses. But what I noticed when I was purchasing these cases of Topo Chico mineral water and Twisted Lime flavor is that every grocery store I was going to was like empty. And just like a couple weeks before, they were stocked. And I was like, oh no, what's going on? So I Googled it. I was like, is Topo Chico going out of business? Because I don't see them anywhere right now. It's crazy. Long story short, the Topo Chico brand is owned by Coca-Cola. And their production of their natural mineral water, not sure how true that is, comes through Monterrey, Mexico. They are rebuilding their facility for the glass production, which means that they're currently more popular and more available in aluminum cans than the bottles. So for a period of time this year, we may not see much more glass until they have the facility rebuilt. So if you see any of those bottles, if you buy any of those bottles,
Just shoot you a DM on Instagram, be like, hey, I've got your glass.
we definitely want the glass. Yeah, cool. Yes.
Do you and Zoe have any plans to extend this practice into other objects?
You know, the cool thing is that we can make a mold for so many forms. I think this mold was really great. This is not with recycled glass, but we could have used it with recycled glass. We're doing plaster molds, like I mentioned, and we can mold plaster into almost any form and blow these reclaimed bottles into lots of different designs and products. They don't have to be cups anymore. So technically no, but the opportunity is very much open-ended.
I guess I was also curious about, I mean, I've been there when you guys were working on it in the early stages of this process. But I'm curious if you guys have experimented with the limitations of how big of a vessel you could make with the bottle.
Yeah. What I know is that most industrially produced glass product, like these bottles or even wine bottles, is formulated to cool down very quickly because they want to be able to puff it up in the industrial metal molds on the assembly line, take the mold off immediately, and have it be stable enough to stand on its own. It's formulated to cool down really quickly. So it makes it very, very, very tricky for us to work with it because the furnace glass, the soft glass we melt at the shop, stays hot and it's like working temperature for a while. And that's what makes it really great for glass blowing. This material technically is not formulated for those approaches.
Right.
So working bigger is definitely more risky. We're probably bound for it to fall off because it cracked off the pipe or cooled down so much that the product itself cracks.
Right.
So scaling up is a little bit tricky, I think. Also, we're using a metal mold that is cast iron, and it has been around for years, and it will outlast and outlive everyone here in this room. Sorry, did I pass that already? No. I just wanted to show you all what that mold looks like. It's in the process. The thing is a tank. It's tiny, but it is heavy as hell. And it's awesome because it has a nice aesthetic texture to it. We really like this imprint. And the best part is that we're not changing the diameter of the original bottle by very much. But if we were going to take some of Shannon's wine bottles and blow them into something else,
Wow.
if we were going to take some of your bigger diameter glass, we would definitely need a bigger diameter mold. And the closer the mold is to the original vessel, the easier it is to get there as far as like a new product. The change in the dimensions shouldn't have to change too much, is what I'm saying. Any other question? No? Yeah.
Is it true that glass is infinitely recyclable?
Yeah, I think it is, as far as I know. It doesn't mean you can just stick something in the kiln over and over and over again. You'll see this effect if you took a cup like this and you put it in the kiln, you fired it, it'll slump onto itself because gravity pulls it down if it gets hot enough. When you pull it out, it might look okay, but if you fire it again, or again, and again, it will end up devitrifying, which is a technical term for basically erosion from the heat exposure. But I don't think that happens when it is at a granular level, when they break it down to make new hot glass as a pool of glass. I don't think you're seeing devitrification in that kind of context. So yes, in some circumstances, it isn't really fireable infinitely, but I do think it is fundamentally recyclable forever. Any other questions? All right, thank you. Also, if you want to see the glasses up close or the stained glass pieces, you can come up